constant, we will get this established. If it's not constant, an obvious question. Okay, good. We have a formula when Ax is constant. If it's not constant, then you will have to look into how did we arrive to this form. What do you? Then we'll
Yes, sir.
have to look for how did we arrive to this form. And when we look for how did we arrive to this form, then we start from scratch. We arrive to this form writing dvx by dt is equal to ax. What did you? We
Yes.
arrive to this form writing dvx by dt is equal to ax. Then comes to us what is dvx by dt. So we know it is time rate of change of x component of velocity, right? Yeah.
Yes,
Time
sir.
rate of change of x component of velocity when read under a rider. And what is that to us? Delta t tending to 0. This is what is symbolized as dvx by dt. Got there?
Yes,
Yes,
sir.
sir.
The understanding change in x component divided by time taken for the change, and then we read it under the rider that delta t is tending to 0. The symbolic representation being dvx by dt, and what is this to read in physics is the x component of velocity. Got all of you?
Yes,
Yes,
sir.
sir.
Now, when we write this, then there is a misconception which somehow gets germinated. And the misconception which gets germinated is there will be X only when there is Vx. Okay? This is what we from here, as per our own figment of imagination, do cultivate. So please weed it out from your imagination. That is not the case. Vx is not to decide on Ax. Got it, yeah?
Yes, sir. The
Because
force will
Yes, sir.
the
decide.
implied meaning of this, see what is the implied meaning of it? Implied meaning of it is okay, Ax we wrote only after Vx, correct?
Yes, sir. So won't AX be there only when force is applied?
Yes. So that is what I was coming to. So let us weed every confusion out here. This confusion should not be in any way so that Vx is to take call on Ax. Vx doesn't call shot on Ax. Ax is governed vis-a-vis application of force. Is it okay, dear?
Yeah,
Yes, sir.
yes.
Because Vx may be 0. Vx may be 0. If Vx is 0, then how we will get a question, very pertinent question, which we may be coming to. That, okay, the particle is at rest, what do you call of Vx? You will say Vx of that particle is 0, right? Yeah. But
Yeah.
Yes, sir.
Vx of that particle is 0 in no way is to say a word on Ax. Person doesn't qualify in any way to say a word on Ax, courtesy what is Vx associated with it. Why so? Because this dt is ambiguous. This dt is ambiguous. Got it here? This dt is ambiguous. By that what I mean? That dt is greater than moment. dt is greater than moment. Now, what I'm trying to link over here, you throw a ball up in air, vertically upward. Got it here?
Yes,
Yes,
sir.
sir.
Yes.
And then the ball, before descending, for a very short period, comes to rest, right, dear?
Yes, sir.
Yes.
Yes, sir.
Momentary. The ball is at rest, correct?
Yes.
Momentary
Yes.
ball is at rest. What will be velocity of that ball at that moment? 0, correct?
Yes, sir.
Yes, sir.
What will be acceleration of ball at that moment? Now
G.
you go to
G.
dv by dt. dv by dt when you go to, it's abstract. Because you don't know what will you take dt, correct?
Yes, sir.
Yeah.
So if you take dt moment means you're talking of that moment. At that moment, of course, velocity is 0, but dt refers beyond moment. Got it, dear?
Right.
Yes,
So
sir.
more than moment. Getting it? Getting the understanding on what dt is? Dt is more than moment. That means dt will take moment minus and moment plus. Getting it?
Yes, sir.
So dt is a span, therefore dt is more than moment. And then you will justify that if you extend moment, then dvx by dt will not be 0. Got it, yeah?
Yes, sir.
Right. Yes,
Then
sir.
dx by dt will not be 0 because you saw for a moment, at that moment velocity was 0, but just before that moment there was some velocity. Just after that moment there will be some velocity, right? Yeah.
Yes, sir.
So dvx by dt, then you can justify if you have the understanding on what dt is. Dt is broader than moment. Got it, yeah?
Yes, sir.
Yes, sir.
And the other is understanding, of course, what Krish was indicative of, that acceleration is the byproduct of force. And velocity you get when you invest on acceleration. Got it, yeah?
Yes,
Yes.
sir.
Acceleration from force, you don't require investment on time. But to get velocity from acceleration, you require investment on time. Got it?
Yes,
Yes.
sir.
Okay. Now, if we know that this is what is AX, and then AX may change, let's say AX is function of time. What? AX is
Yes.
function of time. That means AX is not constant. We went to the basic. Now we write dvx is equal to 5t into dt.
Yeah. Okay.
You know what to do after of this, right, dear? It's
Yes.
mathematics. You know, if it's given to you, acceleration is varying with time, you will go to basic and will start from scratch. Whereas, if is acceleration constant, we qualify uses of this form, right?
Yes, sir.
Yeah. Yes, sir.
Clear to all of you?
Yes, sir.
Yeah. Yes, sir.
Now, I am taking one question to begin with, and a very simple question. What is it being asking on? Please write it down. A particle is moving with a particle is moving with 10 meter per second. A particle is moving with 10 meter per second. When brakes are applied, when brakes are applied to give it a deceleration of, to give it a deceleration of 2 meter per second square. When brakes are applied to give it a deceleration of 2 meter per second square. Find velocity of particle after 10 seconds of brakes application. After 10 seconds of brakes application. Tell you. You can assume the particle to be a vehicle over here, as I spoke of brakes. Got it, yeah?
Yes, sir.
Yes, sir.
Tell.
So it's showing minus 10 meter per second.
Okay, minus 10 meter per second. Correct, dear? Yes, Adesh. Quickly now, on these questions,
sir.
you should be.
So same for me. If minus 10 meter per second square, meter per second, but the car stops after stops before 10 seconds, right?
Okay, yeah, that is what I wanted over here to be pontificated. If it is particle, that's the reason I did sugarcoat it with particle as well as car. Got it? Yeah.
Okay, yes, sir.
If it is particle, then Vx will be minus 10 because particle can move backwards as force being applied through and through. If it's a vehicle, if it's a vehicle, then vehicle after of stopping will not move backwards owing to brakes application. Correct, yeah?
Yes, sir.
So
Yes.
for vehicle, you need to exercise caution, right, Krish?
Okay, yes, sir.
Okay, so if it's vehicle, you have to check, will the vehicle stop or will it continue till 10 seconds, right?
Yes, sir.
And that you will check by placing Vx0, correct?
Yes, sir. Yeah.
So when will vehicle come to rest? When Vx is 0
Yes, sir.
and Vx naught is how much to us? 10, right?
Yes,
Yes,
sir.
sir.
X is minus of 2. So T how
Yes, sir.
much? T equal to
5.
5 seconds,
Five.
right?
Yeah.
Yes, sir.
Yes, sir.
So the vehicle came to rest in half of the time allocated to you, right there.
Yes, sir.
Yes, sir.
Against vehicle, we cannot expect or accept minus 10. So what we should accept against vehicle, tell me dear.
So it'll be this one.
So 5.
It'll
0.
be 0.
0 meter per
Yeah.
second.
0. Yes,
For
sir.
vehicle, it'll be 0. Are you getting it there?
Yes, sir.
Yes, sir.
These are the simple questions they may trick you on. So don't fall for those tricks, correct? Questions
this-
being simple. You're working hard, you know the formula, you're working, but you didn't apply your faculties that it was actually talking about a vehicle. Got it,
Like
yeah?
these questions can be asked in JEE mains. I'm asking, sir. Like they can ask.
Yeah. Now, because now you're talking of mains being on computer-based examination taken, right, yeah?
Yes, sir.
So time factor has seeped in. Okay. And when you are talking of time, then definitely there comes with it dilution. Okay. So
Yes, sir.
papers are now diluted and we cannot be elusive of anything which can be very much in the realm of IIT ask. And these are very much in the realm of IIT ask. Okay. So
Yes.
what happened, Chris? I'm just letting you few terms surface. Formulae we know, but at times we are elusive of application. Application is elusive.
Yes, sir.
However, it wasn't difficult, you know this formula. But when is asked a car, you will have to be very cautious treading that they are asking on something which they know how to check you on. So they are not there to check you on very difficult question. They are to check you on your intellect, right? Yeah.
Yes, sir.
Because they are to use your intellect. It is not that you will be studying these. Once in engineering, you will not be studying this. You will be studying beyond this, right, Krish?
Yes, sir. Yes, sir.
So, what will you say vis-a-vis car or vehicle given to you? And nothing being mentioned that the vehicle is moving on inclined plane. So, we'll take the organic. It is moving on flat surface and it is coming to rest owing to application of brakes, right?
Yes, sir.
So, we know after of a stoppage of car is not to move backward. Will the car descend? No, it won't. Will it retrace its path? Will it happen that way? Say me yes or no?
No, sir.
No, sir.
So in that case, the answer will be 0. But when you're talking of questions where particles being used, now the moment I say particle, and when I am saying particle, I am free to apply on this particle force forever. Correct? I am free to apply on this particle force forever. So
Yes, sir.
you are applying force on this particle and there is no end to that force. But in the car, the moment brakes are applied and car comes to rest, force acting on car. When the car comes to rest, force owing to brake application becomes 0. Say me yes or no?
Yeah.
Yes, sir.
Yes, sir.
So there the answer will be 0. Whereas on particle, if you are to position it, then the answer will be as calculated by this minus 5. Got it, yeah?
Yes, sir.
Yes, sir.
Yeah, yes.
Okay, and stretching it. Just pushing the envelope. Tell me what will be the formula for distance here. What will be the formula for distance here or displacement here?
Sir, x
What
minus x.
formula you have for distance or displacement?
Sir, x minus x naught is equal to vx into t plus half ax into t square.
So that is known to how you get when you write dx by dt and integrate, right? Yeah. So I'm
Yeah.
not going there. X minus x naught is equal to vx naught into t plus of half ax into t square. Okay, this is my second formula. And over here, what is x? What is x naught? Anyone? What is x?
Sir, x is at time
Uh,
displacement at time t, and x naught is displacement at time t0.
Oh, small correction, Krish.
Yes,
X is not displacement. X is position.
sir. Okay, yes, sir.
Okay? X is the position. What is X to you? X is the X coordinate.
Okay, yes, sir.
Okay, X is the X coordinate at t equal to t. What is X naught? In the same forward, NVIDIA. What is X
Sir,
naught? Taking a cue
you
sir,
just
from
said
what?
at t equal to 0.
0. Yeah.
Yes. The X coordinate of particle at t equal to 0, or as we said, initial X coordinate of particle, right?
Yes, sir.
Yes.
Vx naught, Ax naught, all of you do know. What will be x minus x naught if is asked? What will be x minus x naught if is asked? Then you will say that it is the component of displacement in x direction. Got it?
Yes, sir.
Yes, sir.
It is the component of displacement. Even now you cannot say it is displacement. Why? Because displacement is a vector quantity, correct?
Yes, sir.
Yes.
What will you say to be correct? You will say it is component of displacement. In which direction? In x direction. Got it, dear?
Yes, sir.
Yeah, yes, sir.
Yeah.
Okay. Now, if the two formulae being known to you, then I am to first ask you a very simple question, which I am in a way pushing from there. The application being same almost, let me say it got into or not, got into your skin or not. In the previous question, I wish you get me distance traveled by car. Distance traveled by car. Or position of car at t equal to 10 seconds from brakes application. Got it, yeah?
Yes,
Yes, sir.
sir.
Position of car at t equal to 10 seconds from brakes application. So I'm coming from here, I'm carrying this baggage. Got it, yeah?
Yes, sir.
Yes,
Got all
sir.
of you? Okay.
Yes,
Yes,
sir.
sir.
Please further. You are to answer in furtherance. Am I clear?
Yes, sir.
Yes,
Okay,
sir.
please. Distance or position of car at t equal to 10 seconds from brakes application.
Yes,
Sir,
sir.
I'm getting x is equal to x naught.
Okay, x naught you can take 0, Krish, no issue, because x naught is your prerogative, right, Krish?
Yes, sir. Okay, then I'm getting
X
x is
naught
equal
is
to
where
0.
the car was at t equal to 0. We can assume that I have taken the origin to be the position of car. Got it? Yeah.
Okay, yes, sir.
Yes.
This is where the car was, assuming it to be dimensionless. This is where the car was at t equal to 0. So x naught for us, let's say, is 0. Just for it being convenient to us in calculation. Got it, Krish?
Yes, sir. Yes, sir.
Got it, all of you?
Yes, sir.
Yes, sir.
Adin Vedant?
Yes, sir.
Sir.
Okay. So x naught is 0 to us. What will be its x coordinate after of 10 second of brakes application? Yes, Pratyush, tell me, dear. Pratyush,
Yes, sir.
tell me what will be
Yes, sir.
calculate.
Sir, I'm done.
Okay, good. Pratyush, quickly.
So same, you know,
Don't
I'm done.
lag, yeah. Don't lag. This is no time to lax because these are being taken. You cannot be in laxity. You have to solve keeping to time. Tell me, dear. Pratyush,
Sir, displacement is coming 0.
displacement is coming 0. What is this? What do you mean by displacement? X minus X naught.
Sir, can
Yes,
you repeat
sir.
the question?
Firstly, I didn't ask for displacement, Pratyush. I asked for position. So can you be precise? What will be position at t equal to 10 seconds? And this is the time elapsed after of brakes application. Okay? Pratyush, I cannot lend this length of time. I understand. We have to keep track of time as well. Am I clear, Pratyush?
Yes, sir.
So please get me the answer then. Yes, sir means what? Get me the answer quickly.
Sir, here is coming x equals to x naught.
X naught is 0, Pratyush. Why are you doing this, man? X naught I have taken 0. Am I to repeat it? What is X? Tell me. What are you getting X, Pratyush? Pratyush, this way if you are to continue, then you will not be selected for KVPY. Let me tell you. And you will not be furthering also with me. Am I clear? It's not about that I promise you moon and desert you at the time of reality. That is not the case over here. You have come over here after writing a test, right, Pratyush?
Yes, sir.
If I fail in assessing you, then every class is an assessment for me. I want an answer. Get me quickly.
Yes, yes, sir.
I cannot let the other suffer for you.
Sir, 20. No. Wait a minute.
Yes, quickly now. I cannot wait further. Enough, Pratyush.
Sir, 80.
Don't
80
ask me
meter.
question. I want an answer from you.
80 meter.
80. X is equal to 80 meter is what you're saying. And how did you get that? Tell me. What did you do? Quickly.
Sir, x minus x naught is equals to vx naught into t plus half of xt square, and x naught is 0
X minus X naught, which is 0,
equals,
is equal to
yes,
Vx naught how much?
vx to 10.
10. Okay. Then,
10 into 10 t,
okay.
that is
10 into 10.
minus half
Uh,
into 2 into 10 square.
so whatever I did teach few seconds ago is all water off duck's back. Right, Pratyush? Whatever I did say few seconds back, to which you are a nod, yes, 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 is all of no worth, is all water off duck's back, correct? Because you took t equal to 10 seconds. You took t equal to 10 seconds. Can you take t equal to 10 seconds? Can you take t equal to 10 seconds? Answer me yes or no.
No, sir.
What? No, sir. Yes, Krish.
Yes, sir. For the vehicle, it will be x is equal to 25. T is 5 seconds.
What will I do over here? What will be the correction?
Yes, it is 5 seconds because it's already
Yes.
stopped.
Yes. So accordingly, we will get the answer, right here?
Sir.
Okay. And what is the answer coming out to be?
X is equal to 25.
Okay. Is it okay, Adesh?
Yes,
Adesh, did
I
you
got the
get it?
same answer.
So,
I got
am
the
I
same answer.
audible?
Vedant, did you get it?
Yes, sir, 25 meters. Sir, am I audible now?
Are you audible? Are you audible? Okay, so 25, and you know why we will get 25. We can't take 10. We can take 10 for particle, correct?
Yes, sir. It will be
Yes.
5.
Okay, and this was not particle. I told you categorically that we are talking of car, correct, yeah?
Yes, sir.
Yes.
Okay.
Yes.
Yes, if you could have said, as did Krish, that if it is particle, it will be 0. I think it will be 0, right?
Yes. Particle 0.
Yes.
Particle,
Yeah.
yeah.
If it is particle, then it is to reach to the same point from it began its journey. And if it's car, then we'll go by 5. We'll get accordingly 25. Correct, yeah?
Yes, sir.
Yes.
Yes.
Question number 2, slightly raised. Write down. A particle moves on a straight line. A particle moves on a straight line following equation v equal to t minus 1 into t minus 2. A particle moves on a line following equation v is equal to t minus 1 into t minus 2. Find distance traveled by particle in time interval 0 to 3 seconds. Those interval I have taken, right? Yeah. From t equal to 0 to t equal to 3. Got it? Yeah.
Okay.
Yes, sir.
What will it be? I'm timing you, all of you. Please go for it. You have been timed. It's 41 now. Let's see.
Sir, find distance traveled by particle.
In 3 seconds. 3 seconds. 0 to 3. Distance traveled by particle. Distance traveled by particle in 3 seconds. Can please register.
No, no sir.
Sir, done.
Okay.
Yeah, 1 second. Almost done.
Okay. And Pratyush. SGR, it's 43 now. Vedant, Pratyush.
Yes, I guess I did it. I'm done, I guess.
Vedant, what is your case?
Sir, we will get a quadratic or no?
Okay, I don't know. Pratyush.
Yes, sir. Sir, it's 11/6.
And Adish, how much you did get?
Sir, I got 1.5 or 3 by 2.
Okay. Krish, how much did you get?
Sir, I got 11 by
So
6 plus 14, 28 by 6 plus 4.5.
28 by 6 plus 4.5, 11 by 6.
Yes, sir.
Now, the general, of course, what you'll be doing generally is you will take the x component and mark it as dvx by dt is equal to t. You'll expand it and accordingly we'll get to see 3t plus 2, correct?
Yes,
Yes,
sir.
sir.
And then you will go for integration, which is what Adesh must have, right, Adesh?
Yes, sir, I did that.
So, but then, well,
Is the value from 0 to 3, right, Adesh?
Yes, sir.
sir, but then, so one small question.
Dx by dt, I'm writing dx by dt. Got it, yeah?
So one
Yeah.
small question, sir. So
Yes,
here,
yeah.
you have asked distance, no, sir. So won't it be you have to find out where velocity will stop, because velocity
Yeah.
can stop between 0 to 3. So then we
Yes,
have
that
to
is what I was
figure it out.
coming to. I was just clarifying what Adesh must have done. So Adesh must have done this, and after all that, he must have integrated this part, thereby getting 3 by 2 from there, correct?
Yeah.
So your arithmetic being
Oh,
right there, you went wrong on logic.
yes.
Right? And how did you go wrong on logic? You didn't pay heed to that particle can stop and retract. Particle can retract, retreat. Before of t equal to 3, particle can retreat and then can move forward again. Particle can change direction, right there.
Right, sir. Yes, sir.
Not free to move in plane, but even on a line, it can move forward, then backward, then again forward, right? Yeah.
Yes.
Yes,
So you will have to
it's a
rule that
quadratic
possibility out.
equation, so the graph will be parabola.
No, we'll be coming to that later. That you will have to rule out. Graph, parabola, that is VT when you are plotting what you are getting, you can see mathematically. There is not where my concern lies. My concern lies on the physicality of it. You need to comprehend the graph. Graph to you is mathematically whatever is not to me to cut eyes. I am to check that how am I moving? How is that person moving? So that person can move keeping its direction constant. Can happen. Or is free to move backward. He is free to move along the line, right? Yeah. Direction was not mentioned. You can move along the line, forward, backward. You can keep on vacillating, right?
Yes, sir.
So under that circumstances, you'll have to rule out the possibility of a retreat, correct? Yeah.
Yes, sir. So,
Okay, that
do we take, sir,
that you
so
will
do we take,
do straight initial and final. And initial and final, when you will do, you will get this as answer, no doubt about it. But this is not distance, this is displacement. What is
right?
there?
Oh, yeah,
This is
yes,
not
sir.
distance. This is not distance. This is displacement. Why I'm calling this displacement? Because you got the same. You got from here initial, final, and you wrote final minus initial, right? Yeah.
Yes, sir.
You are ignorant to the fact that particle can come back, then can move forward again and land up here, correct?
Yes, sir.
So let us try to figure out what exactly did the particle tread on. And you can from here very well get that there are two susceptible positions for particle to change direction of motion. There are two susceptible positions to change direction of motion. Am I clear to all of you? Clear to all of
Yes, sir.
you?
So, is it at t equal to 1 and t equal to 2?
Yeah, and t equal to 1 and t equal to 2. Very much possible for particle to change Why? Because to change, speed must drop to a 0, correct?
Yes, sir.
sir.
And speed is dropping to 0 at t equal to 1 and t equal to 2. So let us say we are talking of the first interval. So first interval will be from where to where? From 0 to 1, correct?
Yes, sir.
Yes, sir.
Interval will be from 1 to 2, correct?
Yes, sir.
Yes.
And third interval will be from 2 to 3, right? Yeah.
Yeah.
Yes,
So I did
sir.
a mistake there. I took the
Accordingly, we
intervals.
can. Yes, yeah.
I took the intervals wrong. I took 0 to 1, 0 to 2, and 0 to 3. I don't know
That is
what happened.
right. Correct. Krish, it is correct. 0 to
Okay.
1 when you are taking, that will be easier for you. Or 0 to 2, 0 to 3, it will be easier for you to mark on number line.
Okay.
It
Yes,
will be
sir.
easier for you to mark because I want position, right?
Yes,
I
sir.
want position. So I mark it on number line. I take help of number line. We have studied number line, right? Here, why not to make good
Yes,
of
sir.
it? Why not to make good of number line? Why not to absolve myself at least of some effort? I can spare myself some efforts by taking one of the limit 0, right there?
Okay. Yes, sir.
And it is always good to spare yourself of the additional work. See, I'm taking 0 over here, and the first one is 1. And then I find here that t square, when integrated, what will I get? T square integrated?
So you'll get t cube by 3.
T cube by 3 minus 3t integrated?
So 3t square by 2.
3t square by 2. And the last one was plus 2. So what will I get?
So you'll get plus 2t. Plus 2t, yeah.
And then we place limits. Through and through, we have to place limit from where to where? From 0 to 1. When you place limit, you will get this as, check once, is it 5 by 6? Then you will get it as 5 by 6.
Yes, sir.
That
5 by
will
6,
start
yeah.
it from, let us say, x naught. And now it is at x naught plus 5 by 6. Can we say that?
Yes, sir, yeah.
Yes.
Time equal to 1 second. Right, all of you?
Yes,
Yes,
sir.
sir.
Second, I can take from 0 to 2. 0, again 0. And then write the same limits being from where to where? 0 to 2. What you will get is, check what you will be getting is 2 by 3. Are you getting 2 by 3? Just check. Because you don't
Yes,
have to fuck yourself with the lower limit. Lower limit is 0. So you have to comprehend only for the upper limit. You
yes,
get
sir, yeah. 2 by 3.
so x will be how much? X2 rather. Will be how much?
So,
X naught plus 2 by 3, correct?
yes, sir.
So it is here. T equal to 2 second. You get it at x naught plus 2 by 3. Got it here?
Yes, sir.
Yes, sir.
And then the final. Final, all of you must have calculated 0 to 3, correct?
Hmm.
Oh, yes,
And
sir.
when you calculated 0 to 3, you got 3 by 2, correct?
Yes,
So
sir.
somewhere x naught plus 3 by 2. Got it here?
Yes,
Yes,
sir.
sir.
Now you know what to do. It went forward, then did retract. After all that, again moved forward, right?
Yeah. Yes, sir.
Yes.
Calculate distance traveled, which will come as calculated 11 by 6. Is it okay?
Yes, sir.
Yes, sir.
Come equal to 11 by 6. Okay, good enough. Now, going beyond straight line motion. Write down a particle is located. A particle is located on the rim of a bicycle tire. A particle is located on the rim of a bicycle tire at a position shown at t equal to 0. At a position shown at t equal to 0. As the tire as the tire rolls without slipping, as the tire rolls without slipping, find distance traveled by the particle in one complete rotation of the tire. Find distance traveled by the particle in one complete rotation of the tire. Oh, we will not pay heed to wobbling motion. Is it okay, dear?
Yes, sir.
So, tire is to be contained in a plane. Got it, dear?
Yes, sir.
Tire is contained in a plane. We are not paying heed to the wobbling motion of tire. This is tire to me. This tire has got a particle which I am to concentrate my read on. This is the particle, and this is the particle's position at t equal to, let us say, 0. Okay?
Yes, sir.
So it is on the periphery, correct, dear?
Yes, sir. Rim.
So this is what we have. The tire is to and is to remain in the plane xy. Okay. Concentrate on the axis zone. This is the axis zone. Axis of tire. Okay. There are two axes over here, x and y. I'm asking you to concentrate on the axis of tire. Is it okay? Which
Yes,
as
sir.
of now is y axis, right here?
Yes,
As
sir.
of now is y axis. Got all of you?
Yes, sir.
Yes.
Now tire is rolling and rolling without slipping. All of you are aware of what do I mean by it, correct? Yeah?
Yes, sir.
So it is rolling without slipping. Let's say tire now comes to this position. Okay? So what will happen to the axis marked AB? Axis marked AB tilts from the previous position. This is the previous position. Got it, yeah?
Yes, sir.
Yes, sir.
It tilts by what angle? It tilts by an angle theta, where theta is in radians. Got it?
Yes, sir.
Yeah.
First things first. Tell me what will be this distance. Any one of you. Take the lead.
RD theta. RD theta. R theta.
R theta or RD theta?
So R theta in this case.
Very good. R theta. This distance will certainly be R theta. Got all of you why? In one complete rotation, what is the horizontal distance which you will move? Tell me, dear. 2 pi r. Agreed, dear?
Yes, sir. Yes, sir.
Pi r is what to you? 2 pi r is nothing but r into 2 pi, correct?
Yeah.
Yes, sir.
So if 2 pi or theta, as 2 pi we know being in radian, here if theta is in radian, which is what I indicated, then this distance can straight be marked r theta, as did Krish help me on it. Correct, yeah? Correct, all of you?
Yes, sir.
Okay. Question number 2. This is the new position of A. This is the new position of B. I seek x and y coordinates of B. Anyone? I seek x and y coordinates of B. Any one of you?
Theta.
Any coordinate, x or y, whichever you deem easy.
Sir,
Sir,
the
x coordinate will be r theta.
X coordinate will be r theta. Okay.
the y coordinate will be r minus r sin theta. Yeah.
Okay. And x, Are you subscribing
Yes,
to
sir.
what you did say about x coordinate?
Yes, sir. I agree. So
R
wait,
theta.
for why not wait for x?
One thing.
I don't think that I need to tell you how to find coordinates, right? Yeah.
Sir, it's r theta minus r sine theta is x coordinate.
R theta, it can never be. It is impossible for B to have R theta as x coordinate. R theta is x coordinate for point C. How it can be for B?
So it will
What
be
are you
r
saying?
theta minus
Minus
Pratyush,
r
you
sine
are getting
theta.
me all the reasons. Please be very careful, Pratyush.
yes, sir. It will
Okay?
be r theta
Yes, for
minus
yes, yes will not do the wiser on the hind side you cannot be. You are in 12th. This is what you have as the x coordinate. And x coordinate will be how much? Will be r theta minus something. Yes, Adesh, minus what?
Sir, r sine theta.
Yes, please.
So minus r sine theta.
Very good. Because this quantity will be how much to us? This
So
quantity
that'll be
as
r
a
sine theta.
triangle will be r sine theta. Got it, yeah?
Yes,
Yes,
sir.
sir.
So this part will be r theta minus r sine theta.
Sine theta.
X coordinate of B written, which is r theta minus r sine theta. Good enough. What about y coordinate?
R minus r
Sir,
cos
minus
theta.
r cos theta.
Cos theta.
Okay, we'll take that, right? You all are right. This is x and this is y. So y coordinate, as you can see from here, this total is r and minus this part because this will be the y coordinate, correct?
Yes, sir.
Yes.
Yes.
So r minus r cos theta. R minus r cos theta. Okay. Quickly, can you tell me what will it be for A?
For a.
A.
So it'll be r for x coordinate will be r theta plus
R theta plus
plus r sine theta.
R. Yes.
Stay with confidence here.
So
Sir,
r theta plus r
R
sine theta.
Very good. It should eliminate confidence now, right? Yeah, r theta plus r sine theta, right?
yes, sir.
And what
Yes.
about y, ay,
r
R
plus r
plus r
R,
cos theta
r,
plus
plus
r cos theta.
sir, R plus R cos theta.
r plus r cos theta, right? R plus r cos theta, right? Yeah. Got for
Yes,
both
sir.
the points x and y?
Yes, sir.
yes, sir.
Okay. Now we seek distance. As we seek distance, it was asked what will be distance traveled. See for yourself. It goes this way. Are you getting it?
Yeah, yes, sir.
How the particle is traveling. Getting it, dear?
Yes, sir.
Yes, sir.
This
Yes.
path is what is called cycloid. The path traced by particle is called cycloid. Got it, dear?
Yes, sir.
Yes, sir.
Path will be called cycloid. Am I clear?
Sir.
Yes, sir.
And if is given to you a cycloid, suppose this cycloid I am speaking for, then the maximum distance will be how much? Twice of r. Got it? Krish will be using this. So please take note of it. Maximum will be twice of r, right dear? See for
Yes, sir.
yourself. It's going this way, correct?
Yes, sir.
So it goes down and then again it will rise, correct, yeah?
Yes, sir.
Yes, sir.
Yeah.
Okay? In miniature form, it will be this way. Okay, gone up and then down, then again up. What?
Yes,
Yeah.
sir.
Okay.
Yes, sir.
How much will be this distance?
The
This
2 r.
2
this
2
one.
R.
This one will be 2 pi r, correct?
Yeah, 2 pi R.
Yes, sir.
2 pi r, no doubt about it. But this will not be 2 pi r, correct?
Yes, sir.
Yes, sir.
Yes,
We
sir.
are to find the other one. We are to find the other one. Important takeaway, particularly for Krish and Pratyush, this distance will be twice of r. Is it okay?
The twice of r.
Twice of r, where what is r? R is the radius.
Okay.
R
Yes,
is
sir.
the radius, you say, or you can say R is the radius of curvature.
Yes, sir.
Is it okay? You can
Yes.
say R is the radius of curvature. Radius of curvature means take 3 points and join them to form a circle.
Yes, sir.
Radius of that circle is called radius of curvature. Got it, yeah?
Yeah.
Yes, sir.
Okay, just remember, any path given to you, you can easily draw radius of curvature by drawing a circle connecting 3 points which are very close to each other. Got it?
Yes, sir.
Yes, sir.
With one of you, I think I have dealt this. With, I think Adesh, we have dealt the formula. Did we derive the formula, Adesh? 1 plus dy by dx whole square divided by d2y by dx square mod. With you or with
No, sir.
Pratyush, I have.
Not.
Not with you.
No, sir. No, sir. I remember you taking this sum in class one day.
Okay, no issue for now. Just remember, just take it on face value, all of you. Any curve given to you, take 3 points which are very close to each other, correct?
Yes, sir.
And we know that connecting 3 points, we can draw only one circle, right? Yeah.
Yes, sir.
Yes, sir.
Radius of that circle is called radius of curvature. Radius of that circle is called radius of curvature. Now, radius of curvature for what? For the curve. But radius of curvature is of no worth to us unless and until we specify point. Because radius of curvature will keep on changing, right? Yeah.
Yes, sir.
Radius of curvature will be function of
Yes, sir.
position. Yes or no? Radius of curvature will be function of position. Why I'm saying so? Let us see. Let us take 3 points here and draw a circle. Correct here? Now let us
Yes.
take 3 points here and draw a circle. Are they same on shape and size? Shape being same, but size will be different. Correct?
Yes, sir.
Yes, sir.
Shape being same, they are same on shape, of course, they are both circle to register. So shape is same, but size being different. Correct? Yeah.
Yes, sir.
So
Yeah.
radius of curvature is subject of position. Radius of curvature is subject to position of a trajectory. For example, we use it in parabolic path. This is the parabola, right? Yeah.
Yes, sir.
Yeah.
So put about radius of curvature here. You will take 3 points and draw a circle, correct?
Yes,
Yes, sir.
sir.
Will this radius be same as this radius? Will not be, correct?
Yes,
Yes,
sir.
sir.
Okay, so it can be or cannot be. That depends on the shape that you are talking of. As I am talking of parabola, of course it cannot be, correct?
Yes, sir.
So we are talking of radius of curvature being subject to position. That point is clear or not? Radius of
Yes.
curvature is subject to position. Agreed or not?
Yes, sir.
Agreed, sir.
So for this position, what is radius of curvature? Quickly. For the track shown, which I have named cycloid. For the track shown, which I have named cycloid. What will be radius of curvature for this position? Quickly.
So will it be R?
It will be R. Right
R.
here? It will be R. Got it?
Yes, sir.
Yes, sir.
It will
Yes,
be
sir.
R. You can see for yourself why will it be R. Correct?
Yes,
Yes.
sir.
Yes.
And once you have noted that it will be R, also note what is the distance from the datum. This is the datum, correct?
Yes, sir.
So
Yes, sir.
from datum, distance is twice of R. Got it, yeah?
Yes, sir.
Yes, sir.
Remember this, that means the maximum distance from datum of the particle will be twice of radius of curvature, correct?
Yes, sir.
Yes, sir.
Okay. This being done, let us get back to our basic question. Because this additional what I have explained will hold water for Krish and Pratyush more than the other two. Am I clear?
Yes, sir.
Okay. Now, back to the basic question. Basic question being, what distance will it travel in one complete rotation of tire? Now, how we calculate distance? We calculate distance based on distance formula. Any reminiscence?
Yes, sir.
Yes, sir.
Reminiscence of distance formula, what it used to be? X2 minus, tell me.
So
X2
x2 minus x1 whole square plus y2 minus y1 whole square under root.
yeah.
Okay. So x2 minus x1 whole square plus y2 minus y1 whole square and whole under the root, right? Yeah.
Yes, sir.
Let me take 2 points which are very close to each other. Now, why is required the points to be very close to each other? Because you are talking of distance on a line, correct?
Yes, sir.
When you say x2 minus x1, y2 minus y1, you are referring to the length of line segment. Say me yes or no.
Yeah. Yes,
Yeah.
sir.
Yes, sir.
Here we don't have line, we have curve, right? Yeah.
Yeah. Yes, sir.
Yes,
So
sir.
it's incumbent on us, it will be prudent on us to take very small part of this cycloid, correct?
Yes, sir.
Yes, sir.
So as it is imperative on us to take very small part of the cycloid. And why small? Only then we will qualify uses of formula, correct?
Yes, sir.
Yes, sir.
Because for a small part, very small part, for a small part, we can treat it to be as good as a line segment, correct?
Yes, sir.
Yes, sir.
And can then use the formula, but the formula will now shape to dx square dy square under the root. Why so? This one is xy and this one is x plus dx, y plus dy. Got it here?
Yes,
Yes, sir.
sir.
Very close, correct?
Yes, sir.
Yes, sir.
Or distance formula get you, of course, this, correct?
Yeah.
Yeah.
Okay. Now x is known to you, dear. Back to x of b. X of b was r theta minus r, what was it? Sin theta, correct?
Yes, sir.
Yes, sir.
From theta, we took that theta, so according to r theta, it is r sin theta, correct?
Yes, sir.
Yes, sir.
Okay. Now what will be dx from here? Dx will be r d theta minus r cos theta d theta, correct?
Yes, sir.
Yes.
Let's differentiate. So this is dx. Accordingly, dy please. X, y, y, y of b, sorry. Y of x, x of b, no, y of b. Y of b, what is it? Tell me.
R.
R minus r cos theta, correct?
Yes, sir.
Yes, sir.
So dy of b, dy. What will it be? R sin theta d theta. Agreed?
Yes, sir.
Yes, sir.
Now what I do? Place them here. So r d theta minus r cos theta d theta whole square plus r sin theta d theta whole square. Find here.
Yes,
Yes,
sir.
sir.
And all of you under the root. Would you please mind simplifying it?
Yes, sir.
Very simple. You will be getting r d theta outside. You'll reduce to a very simple form. Check once. This one. What will it be? Check. We'll get r d theta firstly outside. Because
Yes, sir.
r d theta is common. Right, yeah? R
Yes,
square d theta square. R square d theta square. You will take it out, correct?
Yes,
Yeah,
sir.
yes, sir.
And then what you get? Tell me after of that what I'm getting.
So then get one plus,
One, one you will be getting, correct?
1
so
plus
and then
1
1 plus cos square theta sin square theta will also be 1.
Okay, so 1 plus 1, fine, take it.
minus 2 cos square theta.
Yeah.
Minus 2
Cos square theta.
theta, okay. This is what we are getting?
Yeah, and it'll be 1 minus 2 into 1 minus sin square, 1 minus cos square theta. So it'll be sin square theta.
Okay, so r, can we take root 2 outside as well in that case? Root 2 r d theta taken outside, can we?
Yes, sir.
1
Yes, sir.
minus, what did you say? Cos square theta.
Yes, sir. 1 minus cos square theta will be sin square theta.
Okay, 1 minus cos square theta. Are you getting 1 minus cos square theta? Will you please mind checking once? Are we?
Yes.
So it will be sine square theta.
This will be twice of r cos theta d theta. And then r square. So twice of r square you won't be getting, right?
Yeah, okay. Yes, sir. Correct. Yeah.
Square.
Yeah. Yes, sir. Yes, sir.
You will not be
Yes.
getting square, correct? So
Yeah,
this
yes,
is
sir.
not,
Correct.
this
Yeah.
is not, please be careful here. So what do we get from here is root 2 r d theta, and then this can be marked as sine square theta by 2.
Yeah, yes,
How?
sir.
How? Cos 2 theta as per trigonometry is either 2 cos square theta minus 1 or 1 minus 2 sine square theta, right? Yeah.
Yes,
Yes.
sir.
I'm using to my suit. I was getting 1 minus cos theta. If it is theta, this will change to theta by 2, correct?
So won't there be 2 sin square theta by 2?
Is it? Okay, yeah, it'll
Yeah.
be 2.
Yes.
Thank you, dear. Correct, correct. 2 sine square theta by 2. Correct, dear?
Yes,
Check,
sir.
dear. Check it.
Sir.
Right?
Yeah.
So one more root 2 out, correct? What we end up getting is 2 r
Sin.
sine square will change to sine theta by 2 when out into d theta. Check it out there.
Yes,
Are
sir.
we? Please do check
Yes,
it.
sir.
Got it, all of you?
Yes, sir.
Yes, sir.
Now you are to integrate this to get total distance. And integration from where to where? From 0 to 2 pi. Correct? Total
Yeah.
angle that the axis will traverse is 2 pi. So from 0 to 2 pi. Tell me what will you be getting after of integration? Test on your integration. Tell me. This is the test on your integration. Can I get from any one of you? What shall I get?
Yes.
The answers.
1 second.
1 minute, sir.
Okay.
So we use integration by substitution, right? We
You're free to use on your free will. I want just the end result.
Yeah.
Use substitution or whichever comes to you. Integration should be your forte, correct? Yeah.
Yes, sir.
Sir, I'm getting 8R.
Okay. So whichever way you go, I find easier changing it to
Theta by 2.
Yeah.
Yeah, yes, sir. That's what I did.
And I multiply over here with 2. And if I have changed theta by 2, then I have to change limits as well because these were the limits for theta, correct?
Oh, yeah.
Yeah.
Keep by 2 and this also by 2, correct?
Yeah, yes,
Oh.
sir.
And then accordingly, as said Krish, rightly so, you'll be getting it as 8r, correct?
Yes,
Yes,
sir.
sir.
When you put 4 over here and sine theta by 2, when you will integrate sine theta by 2, what will you get? Check and place the
Minus cos theta by 2.
yeah. And then you place the limit 0 and pi, correct?
Yes, sir.
Yes, sir.
So cos 0 is 1, cos pi is minus 1, correct?
Yes, sir.
Sir.
And minus minus will make a plus, correct, yeah?
Yes, sir.
Yes, sir.
So inside of bracket, you will get another 2, correct?
Yeah, yes, sir.
Yes, sir.
Therefore, the answer, as did say Krish, will be 8r. Got it, yeah?
Yes, sir.
Yeah, yes, sir.
Okay, more to be seen in the classes to come. I am leaving early because I have to start with another class at 3:30, right, Krish?
Yes, sir. 3:30.
Okay, fine. Thank you, class. Please keep on revising. If you can, buy Krutov as
Sir,
well. Yeah. Yes, Vedant.
sir, ICSE has left us again in uncertainty because
Yeah, I presume, and that is what I have updated. I don't think this year they are to even take IIT. They are saying, I presume they are saying that it's optional, correct?
yes, sir. Sir, they will give us send us messages. Our principal will send us message, and we have to send us back that if we are willing or not.
What about exam? Acha, okay. So that will depend. That very subjective it is. Then how will they come to a conclusion?
So no, that's not about majority. If I will to give the exams or take the exams, I will. That's not majority or voting.
That is what I'm saying. It's very subjective. Is then a
Yeah.
person will have to take call as per individual. I
Yes.
think they will not conduct. Okay, these are all paraphernalia that they are into just an eyewash. They're not to conduct. It will not
So there
happen.
won't be. So there won't be IIT this year.
So then,
Presumably there are talks. There is buzz around IT Advanced being cancelled.
so but then IIT for next year competition will double fold, right?
No, it won't be that way because they will be taking a board examination as well as mains into consideration. Once one examination was conducted by IT, right?
Oh, yes,
Yeah.
sir.
So that if
So
there is not
yes,
much of protest, then they will go with it.
so the syllabus will not reduce for
Of
24.
IIT, I don't think will reduce, but board they are mulling proposal to reduce. IIT, I doubt.
Yes, sir. So from tomorrow, my full day classes will start till 3 o'clock, sir. It's
Okay,
confirmed from tomorrow.
okay, no issue. We'll keep
Thank
after the in that case. We'll try to fix it. Okay, thank you, class.
Thank you, sir.
Thank you, sir.